All right. Hello, everyone. Welcome back to Historical Geology 1404. Do you know what today is?
Wednesday.
It is Wednesday of week 2, which means exam review day. Yeah. So, let's talk. What questions do you have for me?
We've gone through 4 lectures, right?
4. Yep. All of which have been pretty much 1403 review with a few new things in there, right? So, if there's any of that stuff that you have any doubts on, let's focus on that today. I want to make sure you are well prepared for this exam. Hi. How you doing? Good. What you eating? A protein bar? What brand? What's your favorite brand of protein bar? Don't know. Just whatever's there. I gotcha. I like those Quest bars. Pretty good. And they travel well.
Have you tried the barbells?
Barbells? No.
They're pretty good.
Yeah?
They don't feel as heavy.
They don't feel as heavy? Oh, okay. Yeah, that's nice. Except the ones that don't feel as heavy, the ones that are a little bit lighter, I find are the ones that are also the most crumbly. So I like the Quest bars because yeah, they are dense, but they're like Play-Doh. You know, they can bend. You can squish them into a pack or something. Usually, whenever I go caving, I'll be in there for 5 or 6 hours. I'll only take 1 water bottle and 1 Quest bar. Yeah, I mean, it's got enough calories to keep me going for an entire day, if you come right down to it, right? I hardly ever even eat it in the cave. I usually eat it when I come back out. But if I'm ever trapped in the cave, it should keep me going until rescuers come for me. That's the point. And then a bottle, very useful, because after you drink all the water, you can refill it again. Yeah. Yeah, that's what I'm talking about. Okay.
Would there be any stratigraphy over the test?
Stratigraphy? The topic of stratigraphy absolutely may be on the test. Yeah. What? Oh, that's a good question. I am almost certain there are 20 questions on the test. Let me double check that. I may have removed a few.
We can always do the lab again, but not the exam, right?
No, there are 20 on this one. Huh?
We can always do the lab again.
Labs you can do as many times as you want. You are limited only by the amount of effort you put in, and honestly, the other limitation is when I have time to regrade your 2nd and 3rd and 4th whatever attempts, right? Which I'll do as quickly as I can. But there may be a little bit of a delay on that. Okay, so great question. Stratigraphy may be on this exam. 20 questions on the exam. And the format is all the usual suspects, right? Heavy on the multiple choice and fill in the blanks. Light on the short answers, but they are still there. Oh, by the way, how many of you are going to be using ECISD laptops for this? 1, 2, 3. I would recommend, if you have any other option, to do that. Take that option. Because ECISD firewalls have been known to block some of the pictures on this exam and other exams in this class. Now, I'm not entirely sure why your school's porn filter would take out a picture of a fish skeleton, but it does. So here we are. I highly recommend that you use another laptop, another computer if you have that option. If you have the time and permission, you can go to the LRC and use one of their computers. My students do that all the time. Totally fine. And it's 20 questions, and you should be 500 limits. I mean, 500 minutes. Yeah, 500 minutes, right? 20 questions, 500 minutes. More than enough time. Plenty of time. Bags of time, right? Go spend an hour and a half or so at the LRC if you have that option. Cool. Great. It will be on Blackboard. It is the first item in the week 3 folder. And the only reason why it's there is because sometimes, I think last time I taught this class, there was a holiday during the first 2 weeks, or for some reason school was closed for the first 2 weeks, and so I had to shift it to week 3. And I haven't moved it back. You know what? Because that bothers me to say that, I'm just going to move it to week 2. Makes no sense to keep it here. And there, now it is underneath lab 2. So when I open it, that's where it'll be. Let me just change, the due date is off by a day, so give me a second here. I'm going to give you until Sunday at midnight. Sound good? That gives you 5 days to take this exam. Does that sound fair? As long as you have it in by the next time we meet. Because ideally, what we will be able to spend a few minutes maybe discussing some of the things about that exam when we meet on Monday. Cool? And if everyone's completed it by then, which please complete it over the next 5 days, plenty of time to take the exam. Hopefully we can have a discussion about some of the things that as a group we were unsure of and get you that much more prepared for the next exam. Okay? So I will make this due on the 6th at midnight. Hold on. Well, 12 a.m. is midnight, right?
Yeah.
It's a.m. I can never remember. Is midnight a.m. and noon's p.m.? Noon is p.m. Okay. Identification? Some, but not fossil identification. Okay, so we've talked about, not just in lab, but also in the class, we've talked about certain rock and structure identifications, right? Those are very relevant. So yeah, those will be on there. Sedimentary structures. Yeah, that's something that we spent, especially on Monday in our last lecture, that's something we spent a lot of time on. So that's worth a review. Good question. Y'all were here on Monday. I think everyone in this room right now is here on Monday, right? So we're good on that. Yeah, shoot. Oh, here, give me a second here. All right, there we go.
I'm not sure exactly what this is. Some sort of without.
Well, let's work on this as a group, if you're okay with that. Let's use this as a review opportunity. Everyone go ahead and open up Lab 1. What do we have on the bottom here? Oh, it's a label. Everyone go ahead and open up Lab 1. We're looking at question 9. What sedimentary structures are these?
It's just a piece of tape.
Yeah. Oh, sorry about that. Now, interestingly enough, when it comes to identification of any kind, pattern recognition is your biggest ally. That comes easier to some than others, but whether it's minerals, rocks, math equations, fossils, stars, designs on a diaper, whatever it is, okay, whatever you're looking at has some sort of pattern to it. That's the way that things work in nature. Humans make patterns all the time, right? We are an aspect of nature, so that makes sense. But when we're looking at a mineral, what are the patterns we're looking for? Things like the properties, hardness, crystal form, shape, any cleavage we can see, all those things that we learned about and that you might still have nightmares about to this day, right? Those are all patterns, though, and learning to recognize those patterns is how you were able to identify those common minerals. When it comes to structures, it's much the same. If I were to show you layers of rock going at an angle and then layers of rock flat on top of it, you would instantly recognize that pattern. You've seen it enough times now that you would be able to say, cross-bedding, right? Because that's what it is. You've seen it a bunch in my classes now. Now with this question, question 9, see if you can verbalize what those patterns are. Question 9, lab 1. Someone use words to try and describe what you're looking at there. Abstract shapes. Describe the shapes, though. Are they all abstract, or do they remind you of something? No wrong answers here. Just throw out words.
Bony.
Bony, okay. What else? Muddy. All right, kind of looks like dried mud. Bless you. What else?
Something hardened or something that hardened.
Something hardened, okay. The patterns, though. Someone described these patterns earlier as bony. Anything else that they remind you of? Yeah, the shape. What do the shapes remind you of? What shape patterns? Okay, so fossil, that's the second time someone says fossil. That's a conclusion. Remember, we go through a process. Observation, then hypothesis. So anyone else want to offer any more observations before we move forward with a hypothesis here? Do they look maybe like sticks or pieces of plant in any way? Branches?
Oh, they have like roots, kind of?
Right, there's some things that kind of remind you of tree pieces, right? Some are thicker and some are thinner, but they kind of branch off of each other almost like tree parts do, right? That might be another observation you can make. So now with these observations, what is a conclusion we can draw? What is a hypothesis, I should say? Based off of the patterns of these traits. It looks like it was organic. Something was alive, making this, in fact, a fossil. What kind of fossil? It could be plant fossils. Just by looking at this picture, it might very well be plant fossils. They've got those sort of dendritic branching patterns that are common in plants. But regardless of the type, is everyone fairly confident in saying that these are fossils? Good. That's what they are. 99% of identification is just going to be pattern recognition. A lot of the time, if it looks like a duck and it quacks like a duck, it's a duck. Every now and then, in geology and in science in general, 1% of the time, every now and then, you'll come across an exception to the rule. Sometimes 2 plus 2 is somewhere between 3 and 5 in science. The laws don't hold up absolutely all the time. But most of the time it is. Okay. What else? Good morning. How you doing? Good. What else?
So the difference between marine and non-marine is basically ocean-based and non-marine.
Yeah. Marines carry big guns and do naval warfare. Non-Marines, Army, Air Force, right? No. The word marine has to do with the ocean. Okay? Anything within or often proximal to the ocean. Okay? So, for example, a beach environment, I would still call a marine environment because it is at times encompassed by the ocean. And the organisms preserved there are largely ocean organisms. Non-marine, that includes, lakes, glaciers, deserts, anything on land that has no influence from the ocean. Okay. We are reviewing Module 1 for the exam 1 that opens today. It will be closed on Sunday at midnight. Yeah, so all that structure is fossils. That's all you had to tell me, right? I haven't really gone into helping you understand what the different fossils are yet. We're going to be starting that here in Module 2 and going into it a lot more in Module 3, okay? Which is why I said Labs 3 and 4 will probably take a chill pill on for a couple of weeks until you've gotten more of those subjects under your belt. For now, though, unless I specifically ask, like you mentioned stromatolites, it's because we spent a little bit of time actually discussing stromatolites, it's very well that stromatolites may appear as a subject on this exam. But I won't, hold up a bone and say, tell me what kind of animal this came from, right? I won't do that. What? I mean, I never say never. What was I going to do? There was something I was going to do. I was going to check something. Now I don't remember what it was. Oh well, it'll come back to me. Probably around 2 a.m., but it'll come back to me. That's how it works. You always remember at the least helpful times. Oh, I was going to check and see if any of my online students sent questions. Someone liked my Lecture 2 video. Gives me a little thrill inside. Yeah, so they're all on my YouTube channel. They're public for anyone to watch. Someone in Argentina could watch my videos, right? Like the ones that I'm doing in this class. I upload those the day that I record them. So all of our lectures from this semester are up on my YouTube video, on my YouTube channel. Yes. And that's because YouTube is a much easier system to work with than the systems that Odessa College has. So instead of waiting an hour and a half to attach my video recordings to Blackboard, I spend 10 minutes putting them on YouTube and then attaching a link from YouTube to Blackboard. It makes it's just, I get the product out faster, It's just it makes more sense. Okay, those aren't questions, but I'll need to address that later. Okay. Okay. It doesn't look like I've gotten any questions from my online students. Okay. So, what are the questions you have for me? Or anything. We can literally talk about anything. You want to talk about the universe? You want to talk about black holes? Who wants to talk about black holes? You want to talk about black holes. Black holes are awesome.
Let's talk about black holes.
Let's talk about black holes. What do you know about black holes?
Light cannot escape it.
Light cannot escape it, but why?
Einstein said that.
That's why we call them black holes, right? Not even light can get away. Well, black holes are super gravitational bodies, basically. What are they made out of? An excellent question. They are made out of nothing and yet everything, for all we can tell. They exert the most powerful gravitational forces in the universe that we can observe, and cause other objects to orbit around them, much like stars do, right? But where a star outputs radiation, including many wavelengths of light, black holes are much the opposite. They pull things in towards them. Not even light can escape, like Alan mentioned earlier. So the only way that we can even see black holes, that we can observe their existence, is by seeing matter and light spiraling into the disk of a black hole and getting pulled. We don't know. We don't know where they go when they go into the black hole. But here's the deal. Time works really weird. And somehow, it seems to be tied to gravity. The closer you are to an object of great gravity, the more time slows down, or I should say, speeds up for you and slows down for the rest of the universe around you. If I had an identical twin, let's say that me and my brother, my identical twin, are born at the exact same moment, okay? Then our biological clocks are ticking at the exact same rate. If my brother goes on to become an astronaut, goes into a spaceship, and then flies away, maybe he goes to Mars, maybe he goes to the edge of the solar system. Let's say we have engines capable of doing that. He's gone for 10 years. He will come back, and to his perspective, his aging will have continued at the same rate. But his aging, to my perspective, is not the same. He will come back and be, what is it? I'm trying to remember what the calculation was. A week? He would be about a week older than me. This is very, very interesting. Actually, they've studied this. There were a pair of identical twins.
Have you seen the Buzz Lightyear movie?
Buzz Lightyear?
Yeah, the Buzz Lightyear movie.
No.
What you're saying is like kind of the whole plot of that movie. Like he'll go out and like go out in space, but each time he comes back, he's like the people around him are
Have changed.
yeah, have changed.
Yeah, exactly.
Yeah, it looks like-
Exactly.
It's also pretty much an Interstellar as well.
Oh, I'll get to Interstellar in a minute. Okay. So there were a pair of identical twins that became astronauts, and they sent one up into space for a year, and they kept one on Earth. And that guy was just in space. He was just on a space station for a year, and he came back, and they were able to tell by looking at the aging of their DNA that he had aged differently than his brother. Not by much. He was only in orbit, so it was only by a matter of maybe a few minutes, but enough to tell. Okay? So here's an interesting idea. If a supermassive gravitational object like a black hole can distort gravity and distort time, the closer you get to a black hole, the slower time goes for you relative to the rest of the universe. So if time slows down near a black hole, then at the very center of a black hole, that moment that you are pulled completely into it and you're looking out at the universe, you see the entire life of the universe pass before you in one blink. Right before the moment when time stands completely still. Theoretically. It's fascinating to think about. Just being in the orbit of a black hole would slow down time for you immensely. Now, to that point about that Interstellar movie, this is actually a plot point. Have you guys all seen Interstellar? Fantastic movie for a couple of different ways. The first one is that there's a planet that they go to that is in orbit around a black hole. And so a big part of this is every hour that we are on that planet, 7 years passes back on Earth because we are so close to the black hole. Bless you. And so they go down there and they're there for a couple of hours before they can finally get off. And they get back up into orbit, and he calls home, and his daughter has gone from like this cute little 11-year-old girl to in her 40s. And it's kind of a whole heartbreaking thing of the show, because he promised he would only be gone for a few months. But another very good part of that movie is the fact that when that movie came out, when Interstellar came out, I guess this is kind of spoilers, but it's been out for 10 years now, I think. So if you haven't seen it, then what are you doing? A whole point of this movie is that at the end you realize that the people who they thought were communicating with them, that they thought were aliens communicating with them, was actually humans from the future communicating to them through gravity. They were influencing gravity in the now from the future. And this is where they kind of tie the whole gravity and time influence thing, which when they made this movie, I think it came out like March or June or something like that of that year. Later that year, I think in November, astronomers actually observed the collision of two black holes and watched what can only be described as ripples of gravity. And it affected the wavelengths of light that we observed from the nearby stars, so that we were observing the wavelengths from those stars at various points in the future and from the past and back and forth. A ripple, basically, in the time that we were observing the photons from those stars. And so what at the beginning of the year was science fiction in Interstellar actually became science fact. It is conceivably possible that if, and this is all things in nature, if nature can do something, it is theoretically possible that we can as well. Right? Think about all the scientific things that people thought were science fiction. If you ever watch the old Star Trek movies with Captain Kirk, they whip out their communications devices. You know, it looks like a Razor cell phone. And we got those. Right? Elevators were science fiction. We got those. Right? Submarines were science fiction. We did that. Watches, science fiction. We did that. Anything that humanity's imagination can come up with, we've pretty much made it happen, or are in the process of making it happen. If nature can do a thing, we can too, given enough time and the right resources. If there is natural manipulation of time using gravity, we can do that right too, using the right resources. Very interesting thought. The whole thing that Interstellar may basically, it may actually happen one day. Being able to communicate with the past or maybe even the future through an understanding of gravity. Travel? No, that's not the same thing. Yeah.
What about the beginning of the movie? Like how Earth is dying, and all the buried?
Yeah, the beginning of the movie is pretty much a global catastrophe morality lesson. So there's been a big war. It kind of messed things up. Global warming spiraled out of control. there are different pockets of humanity trying to survive around the world. It's not like a zombie apocalypse or anything like that. There's still some semblance of government and organization. There's just a lot less people, and everyone acknowledges the fact that the Earth is dying, and it won't be able to support human life for much longer. So the whole point of the movie is they are sending these astronauts out. They sent astronauts to like 4 or 5 different planets to try and figure out which one of them would be best for humans to start living on. And then at the end of the movie, they have found one. And so they pack everyone up, basically. They pack all of the rest of humanity up into a giant spaceship, and they go to that new world. Possible, but over a much longer timeline. Have you ever seen Passengers? With Chris Pratt and Jennifer Lawrence, thank you. I was going to say Katniss Everdeen, right? Yeah, great movie. The basic plot, without giving any spoilers away, of that movie is that these colony ships launch from Earth, and then they fly through space for 80 years before they reach their destination. Kind of having to do with that thing I told you all about, right? The Fermi paradox. You remember I told you about the Fermi paradox a couple weeks back, about why we haven't seen any aliens yet and why it doesn't kind of make any sense if they're out there, all of that, right? Takes 80 years traveling at 10% the speed of light or so, right? If we made the right engine and we could propel at the right speeds. Technically speaking, you can accelerate indefinitely through space. You know that? We only have an acceleration cap on Earth because of atmospheric resistance. When you break the sound barrier, that's you going past the speed of sound and you're cracking through the air, right? You've broken sound barrier and it makes that loud noise. In space, there is no resistance other than gravity. So theoretically speaking, you can accelerate an object indefinitely through space, at least until you hit our current cap of the speed of light. As far as we're aware, that's as fast as things can go. But without deviating too far, we can theoretically, or some things can go faster than that. But I'm not going to talk about that right now. Okay? Speed of light being the hard cap in space. But if we make an engine capable of going maybe 10% the speed of light, that would be an incredible achievement. We can do it right now. We just don't have enough money to pool together, and we don't have enough cooperation from all the planets. We could make that engine right now. We have that technology. Maybe we will one day. But 80-year trip to another planet, there are 2 ways you can do that. Either it's a generation ship, which means that I go with my family, I live and I die on that ship. My children live and die on that ship, and their grandchildren are the ones that ultimately go on to settle that world. That's a generation ship. Or what you can do like they did in Passengers, you just freeze everyone. Cryogenic storage, basically, for 80 years. And then you arrive, and the original passengers wake up, hopefully, to settle that world. Cryogenics is still a matter of science fiction. We've come close to some things. We can cryogenically store organs, but not something as complex as a living person yet. At least not that I'm aware of. Some millionaires may have figured it out. Bill Gates might have a cryogenic storage unit somewhere. But yeah, as far as I'm aware, we haven't cracked that. But that's far more likely, where you have those long time periods between point A and point B. Yeah.
I've heard the Milky Way is going to run into a new galaxy.
Yes.
Years, so
I believe it's the Andromeda Galaxy. Yeah. So our nearest galactic neighbor, the Andromeda Galaxy, and we are going to collide in about, I want to say, 2.4 billion years. So yeah, not really something that we need to worry about. But the closer we get to each other, the more gravity is going to influence. Our gravitational forces are going to influence each other. Every galaxy has a supermassive black hole at the center of it. That's why there are things spiraling around a point in space. All things spiraling around a point in space, we call that shape a galaxy. And there are millions of galaxies in our universe. At the center of each is a supermassive black hole. So us and Andromeda are spiraling through the universe, going towards each other, and eventually they're going to crash into each other. We're on the outer middle arm of one of these arms of the galaxy. You know how we've got that spiral? It kind of looks like a saw blade with much longer teeth, right? We're in about the middle outer edge of one of those arms, which, depending on where our arm is, our solar system may experience that collision before most of the rest of the galaxy. But ultimately, what will happen there is the collision of these two galaxies will cause tremendous chaos, lots and lots and lots of exploding stars, whole new gas clouds in space, and effectively it will force a recombination of all the matter in both of these galaxies into a newer, probably bigger galaxy unit, given another probably 5 or 6 billion years after the collision. I have no idea what the two black holes will do when they crash into each other. It's very possible that two supermassive black holes colliding with each other will annihilate or pull in everything. Oh, and here's another interesting thing about black holes, going back to the whole black hole conversation. There's a very fascinating theory about what black holes really are. They're really inexplicable with our current understanding. You should really listen to Neil deGrasse Tyson talk about black holes. He's so enthusiastic about it, he'll talk your ear off about all of the stuff, and then openly admit, but I mean, this is all theory. We really have no idea, at the end. But there's some fascinating theories. I think my favorite, it sounds kind of far-fetched. There are actually two that are my favorite that both sound kind of far-fetched. The first one has to do with that Fermi paradox. Let me refresh your memory on the Fermi paradox. Basically, the Fermi paradox states that since our galaxy is so old, there should have been intelligent life that have colonized it already. Do you remember this? Where if you take into account that it takes maybe, say, 80 years to go from our planet to another world, and then 20,000 years for that small group of humans to spread their civilization across the planet and reach the space age again and send their own colony ships out, 80 years, and then 20,000 years for that colony to reach the space age again and send their colony ships. It should only take about 300 million years for any one intelligent species to populate the galaxy. 300 million years. And yet here we are in a galaxy that is 5.5 billion years old. And it appears to not have been populated. At least not this world, and there's no evidence that we can see on other worlds. And there's no radio transmissions, or there's nothing like that. There are no relics of life that we can observe. That doesn't mean it didn't happen much, much longer ago, but it just means that it hasn't happened in our part, at least within that time frame, which is weird. If life is as common as we think it is, why hasn't that happened? Well, maybe intelligent life isn't as common as we think it is. Or, here's the other thing. Something happens to that life before it can spread out that far. Something inevitable happens to that form of life, to that intelligence. Some people think that it is self-annihilation. All intelligent species are destined, so to speak, to annihilate themselves before they reach that point of technology where they can spread out that far. Others think that they reach some sort of singularity, a point at which these beings' intelligence grows to the point where the intelligence surpasses the physical domain, the physical realm, and ascends, so to speak, to a higher plane of existence. Now, those people tend to think that it has to do with black holes. Because we cannot explain black holes tend to be simultaneously the boogeyman and the savior of a lot of these theories. A lot of these people who believe in the singularity theory believe that black holes are essentially giant memory disks. collecting matter into themselves, pulling matter into themselves endlessly, and essentially working as hard drives within which all previous intelligent life is residing. Essentially, a natural occurrence that some intelligent species, that all intelligent species possibly, are destined to figure out how to access through means of technology, one way or the other. And upon accessing that technology, essentially upload themselves, if we are to think of it like that, into that realm, into that reality. That's an interesting theory. Nothing really to back it up, except that black holes are really inexplicable. And they may work like that for all we know. The next one that I like, which I think I like a little bit more, is how did the universe begin? The Big Bang. Where did the Big Bang come from? Don't know. Neither does anyone else. It was simply a whole bunch of matter that exploded out of nowhere as far as we can tell. What if black holes were holes, exactly that, in our universe that bleed our matter, our mass, into brand new universes on the other side? So every black hole essentially is pulling matter from our universe, streaming it through this hole in reality to another universe, initiating a Big Bang in that universe, where once there was nothingness. What an interesting idea that is. But that comes with its own problems. If all matter in our universe is destined to get pulled in and shunted through to another universe, and each black hole is going to a different universe, initiating a different Big Bang, eventually you run out of enough matter to have enough universes and enough galaxies and enough everything. It all gets siphoned away, spread out too far, too thin. So either we're not very far along in that overall pattern, or that mathematically can't work out. Yeah?
I know in Switzerland, there's a lab that's trying to recreate the Big Bang.
You what? I'm sorry?
There's a lab in Switzerland. It's called CERN.
CERN. Oh, the CERN. Yeah, the CERN lab. Yes.
Trying to recreate the Big Bang.
Yes. CERN is always trying to recreate the Big Bang. They're trying to. That lab. They have what's called a particle accelerator. A particle accelerator is exactly what it sounds like. You speed up particles to the speed of light and then slam them into each other. It's miles and miles. I don't remember the exact number, but there are miles of this facility where it's just basically one continuous tube where they speed it up until it reaches close to the speed of light, and then they slam that particle into another particle. And that's where most of these man-made elements come from. For a very short period of time, new elements are formed from this collision. And if it can exist for a picosecond, we put it on our periodic table and call it a new element. So we get a whole bunch of exotic particles. So there's a lot of work going on in CERN for understanding things like the Big Bang. However, there is an element of danger that comes with this, because they're playing with forces that we do not entirely understand. It is entirely possible that they collide the wrong things and it starts a black hole. We have no idea how black holes start. Maybe it's from an unfortunate collision of hyper-accelerated particles. And we're just playing around with it, right? We're not entirely sure. But, they keep testing. There's actually a fascinating book series that I read called Empyrean. Or Hyperion, Hyperion. Science fiction. Great series, though. But the basis of the book series is that humanity had to flee Earth and go to the other planets in the solar system, and then from there to other planets in the galaxy, because the CERN particle accelerator made a black hole. They call it the Big Incident of 2008. This book series was written in the 90s. Okay, but in the big accident of 2008, a black hole was accidentally spawned on Earth, and over the course of a decade, slowly pulled Earth into itself. And so everyone had about 10 years to get off of Earth in whatever spaceships they could. And that's where it's basically more or less become an empire over the last 600 years, right, in this series. a far galaxy spanning empire, but they were forced to flee Earth because it got pulled into a black hole, and now there's a black hole sitting where our solar system used to be because it eventually pulled in our sun and all of that. So, fascinating ideas, fascinating things going on, fascinating science. It really fires the imagination.
There's one other star I was kind of wondering about.
Yeah.
Neutron stars. Or whatever.
Neutron stars. Yeah. That is also a big mystery. Neutron stars, the only thing that I can confidently tell you about neutron stars is that they are more dangerous to hang out by because they bombard you with heavier radiation. I haven't put a whole lot of research into neutron stars. Other than they're difficult to see. They can be difficult to see. There are a lot more different varieties of stars than you would think. There are white stars and yellow stars and blue stars and red stars and brown stars. There are black stars. There's no green stars, though. Interestingly enough. Green is not a wavelength that stars exclusively put out. What color is our star? Yellow, orange. Yeah? Yellow, orange? If it were yellow or orange, snow would be yellow or orange. Everything that we see as white would not be white. Our star puts out white light. It only appears yellow to us at different points in the day, or orange, because of the amount of atmosphere and what's in that atmosphere that is diluting the light. So you're only seeing certain wavelengths. But the light that is emanated from our star is pure white. Otherwise, we would have no white things on Earth, because things that have color are reflecting the wavelengths. Okay? But we can look through telescopes and we can see red stars and brown stars and all of those. Those do exist. The sun will be white. Yep, pure white.
Have you been to the observatory in Fort Davis yet?
I have not been to the observatory yet. I would love to take my kids, though. That would be a blast. Maybe I should do that over the summer.
I haven't taken my kid yet either.
Yeah, I gotta do it. That was a fun tangent about black holes. Yeah.
Why isn't Pluto a planet?
Why isn't Pluto a planet? Wow, we're hitting all the good stuff. I think I've explained this once to y'all, maybe in 1403. Do you remember? Yeah? What do you remember?
It's too small, and it orbits around its moon.
Ah, there it is.
Orbit around each other.
Right. So yeah, it is pretty small, but people were willing to call it a planet when we still knew how big it was. The big clincher, though, is its size relationship to its moon. Pluto's moon is about 30% the mass of Pluto, which is massive enough that Pluto orbits its moon while its moon is orbiting Pluto as well. So the moon, has more motion, but Pluto is still trapped in an orbital relationship with its own moon, which means that its center of gravity is not actually in the planet itself. The center of gravity for Pluto is between Pluto and its moon, which means that if we were ever to land a spaceship on Pluto, it would not stay there. Gravity would pull it off the surface and into space between it and the moon, which is why landing or living on Pluto is not a realistic expectation. Huh? Yeah, so if you were able to land on the side of the planet exactly opposite, so there is a 180-degree relationship between where you are standing, where your spaceship is, and the moon on the far side of the planet, then center of gravity is pulling you towards the planet, and it would feel like you are successfully standing on that planet. But if it could, it would pull you around the side of the planet and off of that planet. That's really the only circumstance in which you could stand on Pluto.
Like, if the you were talking about galaxies,
Yeah.
the black hole and solar system.
Mm-hmm.
If the black hole stayed there, it would rotate around the supermassive, so it would be part of the galaxy. Or would they?
Yeah, all things in our galaxy rotate around that black hole. So here we have, this is going to be a terrible galaxy picture, okay?
Like Sonic the Hedgehog.
Right, if Sonic's head just kept on going, okay? Call that our galaxy, okay? And our supermassive black hole here in the middle. The closer you get to the supermassive black hole, the heavier gravity is. But also, the denser the radiation is. Like if these are all different systems, star systems, right? And they're all densely packed close together because they are closer to the source of gravity. The stars and black holes and planets and everything closer to the center are constantly colliding with each other, generating so much radiation. Like that's anywhere in space for hundreds of light years around this black hole is unlivable to anything like you and me. We would be, our cells, everything about us would be shredded, right?
And they call that spaghettification.
Huh?
Spaghettification.
Spaghettification is theoretically what would happen if you get pulled into a black hole. Remember how I told you, if you're getting pulled into a black hole, right there, that moment as you are in the center and time is going so fast for everyone else but you would see the life of the universe in front of you. Like from the moment you entered to the end, you would see the universe die in that moment before you got pulled in because time is going so fast for you. Well, think about this. Your feet get pulled in before your head. Time is going slower for your feet than it is for your knees. And time is going slower for your knees than it is for your hips. Time is going slower for your hips than it is for your chest. Time is going slower for your chest than it is for your head. So while your head is still observing up there at that speed, time is going 1,000,000 times slower for your feet. And so what happens is, theoretically, it's called spaghettification. Your body is stretched out until its molecules, atoms thin, because time is going faster or slower for your entire body, depending on your proximity to the center of that black hole. That is spaghettification. It's kind of a disturbing word when you think about it, right? You're being spaghettified, pulled so thin that eventually you end up as a stream of atoms. Okay, so that's the center of our galaxy. Now, the further we get away, the sparser star systems become. But they are still trapped in the gravitational effect of that supermassive black hole. Okay, so you get the idea. Now, we are about here on one of those galactic spiral arms. We're not the furthest out, but we're still pretty close. We're about halfway and on the outer edge. And based upon observations that we make, it appears that our star system every now and then is between galactic spiral arms. For between 200 to 300 million years, it's traversing the middle of space between galactic spiral arms until we end up in another spiral arm because of the path of our star system around that black hole. Yeah. What was the original question?
Why is it Pluto a planet?
I think that's the one that we had before this. If that's the question that led me here, I went really far astray. Right. Okay, so I was showing you a gravitational hierarchy. Okay, so the biggest, baddest gravitational body in our galaxy is that black hole. Everything else is trapped in the gravitational influence of that black hole, even stuff way out here, right? Next, the next biggest gravitational influence are within your star systems, okay? Stars themselves. There are really big stars and there are small stars, but all of them have... Do I hear sandstone? But all of them have some gravitational effect in space around them. The gravitational effect of our star spreads far enough that we have are sun, orbits of different planets, and at the far edge, an asteroid belt. There's actually 2 asteroid belts. There's an asteroid belt between Mars and the outer planets as well. Okay, but this one on the outer edge of our solar system represents kind of the furthest extent of the gravitational influence of our star. Okay, some solar systems or star systems are bigger and some are smaller than ours. Black holes have the same sort of effect, except because of their nature, they pull things in and kind of gobble up that mass. Okay, whereas a star doesn't really do that. A star emits radiation while a black hole pulls in, and then it's kind of interesting because black holes do emit radiation, just not visible spectrums of it. You can see it if you look through a gamma detector, but it's spitting out. Every now and then a black hole will do what we call a burp, where it's pulling in all of this matter and energy and light, and every now and then it'll burp out gamma radiation, and then burp out gamma radiation, right? Really the only stuff that ever escapes a black hole is that gamma. Did that answer your question at all? You asked what would happen if we did get a black hole here.
Yeah.
Everything would get pulled into it.
Yeah. It was more like, would it get bigger to the point to be supermassive?
I mean, no, you mean like start a new galaxy? No, there are black holes all throughout this galaxy. How this one started is an excellent question. Can multiple black holes combine to form eventually a supermassive black hole? I don't know. We still don't know much about them, and we don't know that much about them. We can see what they do to space around them. That's the only observation power we have, is observing how they affect space around them.
And also, the holes are pulling everything closer. Are we getting closer?
To that one? We're not really getting closer as far as we can tell. As a matter of fact, some things go further and some things get closer. These planar planets are definitely getting pulled closer. But to our perspective, they're barely moving because of the way that time changes the closer you get to the black hole, right? Just like in that Interstellar movie, if Matthew McConaughey's daughter was able to see him, right, it would appear as if he wasn't moving or barely moving for 40 years or 30-something years, right? To him, he's still living at the normal pace. If he was able to see her life would be zipping around doing her life for 30-something years in the matter of a few hours for him. Like if he took 30 years of her life, put it in a VCR, and then pushed fast forward. Do you guys know what a VCR is? Okay. Then you push fast forward, like, right? That's what he would have seen. To us, those planets towards the center of our galaxy are barely even moving. To them, if they could see us, we are zipping around in space around this way, way faster. Time. Fascinating. Time apparently seems to be some kind of force that can be manipulated. We don't even understand, I think, what time is. Is time even real? Is time a product of gravity? If I were to leave my galaxy and be in the space, the interstellar medium between our galaxy and another galaxy, will I even experience time? So many questions here, right?
Have you ever seen that movie Lucy?
Lucy.
You talk about time, like you're saying that time doesn't exist or whatever.
No.
Have you ever seen it? Scarlett Johansson?
Yeah. I think I saw. I haven't seen it though.
It has something to do with the time thing. I don't know how to explain it. but
Ooh, I should watch that.
Pretty much, like, she takes a bunch of, like, fabricated drugs that, like, apparently, like, help her cells, I don't know, if regenerate or grow at exponential rate, and, like, she unlocks 100% of her brain, and, like, she he loses her body pretty much. He does.
But doesn't it talk about like time, right? Like how time doesn't exist?
The whole unlocking 100% of your brain shtick.
Yeah.
Like yeah, that human like made time just to like have a grasp of something. So like
Yeah.
Yeah, but that time doesn't really exist.
Yeah.
Yeah.
If a tree falls in the woods and no one's around to hear it, does it make a sound?
yes.
Does it?
Cool movie though, because that's she explains like to all these scientists like
Yeah.
the I guess like the mathematical stuff. And
Yeah.
how time is
That
not
sounds
really-
fascinating.
how
I think I
time
want to
does
watch
not
that.
really exist.
Like most of it is like the movie's dumb. It's like her assassinating like people trying to get more drugs, but at the very end, like she explains.
Okay, that's interesting. I'll probably want to watch that movie. I like ScarJo. Okay. Although, back to that question. I asked a serious question just now. If a tree falls in the woods and no one's around to hear it, does it make a sound?
I think so. Yeah.
Huh?
Object permanence.
Object permanence. Let's say that we know that the tree fell in the woods.
Maybe an indicator would be the animals running away.
You're not there to observe it, though. And let's say there are no animals. Let's say by you, I mean anything that is capable of hearing. If anything that is capable of hearing is not around, is there still a sound? Let me ask you this. Does it matter? And that right there has to do entirely with human perception. Does anything exist before we see it or hear it? Before humans built telescopes and looked up at the stars, were those stars already there? Really, there's no way you can prove it. Now, this brings me to a totally different theory called perception universe, or fabricated universe, if you will, theory. That nothing exists without being observed. And so therefore, the further that we look, the more we, as simply a product of looking and expecting, are creating. It's a whole different theory. It's kind of, that one's a little out there for me. I don't think that I'm creating a whole new star systems by looking through my telescope.
Oh yeah.
Yeah.
They said that Earth used to have a ring around the planet.
Earth?
Earth, yes.
Oh yeah. We totally did. Yeah, Earth definitely had a ring. Following the collision of Earth and Theia, there was a ring of debris around our planet that eventually either landed back on our planet or coalesced into the moon. Yep. Now, the ring that we have between Mars and the outer planets is mostly made out of planetary debris. Either things that never got incorporated into one of our modern planets, or are the remains of planets that were formed early on in the solar system and got destroyed through one reason or another. And then all of the asteroid belts that are on the outskirts of our solar system are the things that went into making our planets, but that's what's left that never got actually pulled in. Every now and then, Jupiter is the second largest gravitational force in our in our solar system, right? Every now and then, its orbit takes it close enough to that outer asteroid belt that it pulls one of them in, or a couple of them in, and it creates a problem for us, like Apophis, that asteroid I told you all about before that may collide with us in a few years, right? That got pulled in by Jupiter. Some other ones that have had near misses with Earth have been pulled in by Jupiter. Jupiter just likes making trouble. But a lot of these asteroids are made out of very valuable elements. There are some asteroids out there that appear to be made completely out of carbon. Entirely out of carbon. An asteroid essentially made out of graphite, more or less. Right? Very interesting, considering that carbon is relatively rare on our planet. There's a lot of carbon, but it's not as common as many other elements. And yet there are whole asteroids of the stuff hanging out in our asteroid belt. There are asteroids made out of dense metal of the same alloy that we believe our core is made out of. They are chunks of planetary core, basically. There are asteroids made entirely out of ice, which is a big reason why asteroid mining is expected to become a big deal in the coming decades, especially if we start establishing bases on the moon and on Mars. It will be a lot cheaper and better if we can take some ice asteroids and park them in orbit to provide water than if we are shipping water from Earth to those places. Earth should keep its resources. If anything, other resources should come to Earth to help the situation here, right? So asteroid mining is going to be really big.
Is there any way to like properly retrieve the asteroid? Like it's crashing into Earth, like send rockets.
Yeah, we don't want to make them crash into Earth, right? Hey, we could really use this. Oh no, we destroyed Buenos Aires. Oops. Right? No. Ideally, what you do is you attach essentially tow ropes to these things. And then you ever so slightly change their orbit, and this requires a lot of math. You just ever so slightly change their orbit so that eventually they will end up in a stable Earth orbit, or a moon orbit, or a Mars orbit, as the case may be. Mars has 3 moons, I want to say. And they are all trapped asteroids that simply got trapped in Mars orbit. So we would just make that happen artificially, basically. And then you simply have a very large, hundreds of years worth of water reserve up in orbit. All you have to do is break off chunks of it and put it on some sort of vessel and bring it to the planet's surface. Same is true for metal asteroids, or carbon asteroids, or any other asteroids. Huh?
Well, ice asteroids.
Yeah, that's what I was just talking about. Ice to provide water. Yeah. Because Mars has a lot of water at the poles, but you probably wouldn't want to live at the poles. You could ship water from the poles. The moon is harder. The only ice you have on the moon is at the bottom of deep craters or inside of volcanic tubes.
Okay, so I have a question about the solar system.
Yes.
Like, every display we have is like it puts all the planets on like a 2-dimensional plane.
Yeah.
So like, is it or like why isn't it like, let's say you have Earth circling the sun like this,
Yeah.
have a different planet going like this.
Uh-huh.
Why is it all on like a similar plane?
That's a great question. Earth circles, let me see if I can pull up a diagram here. Earth circles our sun along a certain plane. We call it the plane of the ecliptic. Planetary orbits around sun. See if I can find a good 3D version of this. Here we go. That's not bad. Okay. Yeah, that's not bad. Okay. Yep, that'll work. Let's turn this on. Oh. Let me erase my galaxy before I pull this up here. So, where was I? So, Earth orbits around a certain plane, as do every other planet in the galaxy, or in the galaxy, in the solar system. And this has to do entirely with the nature in which our galaxy or our solar system formed. Our galaxy forms a large disk, right? Our solar system formed in the same way. A disk that flattened out, and our orbits are based upon the orientation along that disk. And that disk formed based upon the gravitational pull from the center of our galaxy. Okay? So all of our planets have varying degrees of ecliptic orbit or circular orbit, right? Different distances, but all follow along essentially the same plane. Okay? The same ecliptic plane there. This comet is the exception, right? That's a large comet that passes through our solar system. But and there are a few other comets and asteroids that do the same thing. But they weren't involved in this process while our solar system was being formed. All the planets were, though. So here we have all of our planets going along the same plane around our sun because the disk formed like that, with the sun in the middle. From a cloud to a disk, as gravity forced everything to start orbiting around the center of mass. Say what? Oh, this is our inner asteroid belt. Remember how I told you there was one between Mars and the next planets, right? So here we have Mercury, Venus, Earth, Mars, asteroid belt, Jupiter. Saturn, Uranus, Neptune, outer asteroid belt. Huh? Oh yeah, Pluto's been off for a while. Yeah, so that's an example comet. That's not any particular comet. It's saying that comets and asteroids exist outside of this plane because they are orbiting not based upon their formation during that disk, that flattening of that disk. All the planets are. The comets and asteroids have come along since then.
But then any asteroids that get into the belt and then get inside the solar system, do they do that?
Yeah, they'll usually follow that same plane. If they're being pulled by Jupiter and they're being balanced between the gravitational pull from Jupiter and the sun, then yeah, they will often fall inside of that plane. Anything that comes from outside our solar system, like comets typically do come from outside the solar system. They basically just island hop between solar systems. They are not restricted to staying within that plane. Sometimes they get pulled into that plane because there's a lot more gravitational forces along this plane because you've got the sun plus all of these things in this direction, whereas in this direction there's not as much gravity. So this may eventually flatten out, but it doesn't have to. We've talked a lot about space, which is fascinating, but I want to make sure that everyone has the opportunity to ask their questions about the exam. I love filling your heads with big ideas and big thoughts beyond our world, but I want to make sure that we stay at least somewhat focused, or I give you the time for things that are more relevant to today's exam. So, thought of any other questions? Okay. Well, I'm going to end the review here then.
I have one more. Will the formation of structures be covered? Like,
Sedimentary structures?
Yeah.
Yeah, sedimentary structures will be on this exam. Yep. How we feeling? Good? Claudia, you feel good? Great. I'm going to end the review here.